Hello there, Math 126 fans. Somebody on the discussion board is asking about minimum distance. They're particularly asking about a solution they saw in a different instructor's exam. And before I do that, I want to recap. I will say something about that, but recap these minimum distance questions. So if the question is saying you're trying to minimize the distance to a given point, step one will be to write distance. That's the thing we're trying to minimize. That's the thing we're trying to get a two variable function for. And when we're talking about minimized distance, we're talking about minimizing the straight line distance from some unknown point. This is the homework question. To the given point. Now, if you're allowed to stand anywhere you want, you stand on top of that point and the distance is 0. But if they're forcing you to stand on this cone, then that's your constraint. And we need to substitute that in here. Okay. And we're almost to the question. I just wanted to lay out that first step. In this case, it's kind of nice because you get z squared as this, so you get this. Now, textbooks do something in this moment, and a lot of instructors do it too, and it makes sense to do it, but it's an unnecessary step. If I'm trying to minimize this two variable function, I know what I need to do next. I need to take the partial derivative and set them equal to 0. Yeah, that partial derivative may look bad, but it's really not that bad. I know from experience, so let's say something here. If I have this, I know the derivative of the square root is 1 over 2 times the square root of t. If you don't know that, it's t to the 1/2. And when you take the derivative, it's 1/2 to the negative 1/2, which we can write this way. If you know that, you don't need any other tricks, meaning the derivative of this is, with respect to x is going to be 1 over 2 times the square root of that big mess. And I tell students it's perfectly fine with me if you write that. By mess, I mean the stuff under the radical. The reason that doesn't matter is because I'm about to set this equal to 0. So it doesn't matter what's here. And so I really just need to now do the derivative of the inside, which is 2x minus 6 plus 2x. And the derivative with respect to y is going to be 1 over 2 times the square root of the mess. And then it's going to be 2y minus 2 plus 2y. So I tend to kind of be like, I don't love these tricks that get rid of this small thing because they add so much confusion. It's not wrong. I can say a little more here. It's good to ask about these things. It's good to be exposed to them. But this little maneuver about ignoring the square root is not essential to the problem. From this, we get x has to be 3, we get y has to be 1. It's a fairly quick problem. Now, there is something I can say about square roots in general, which is that I know without actually looking at my calculator which one of these two numbers is bigger. How do I know that? Because I know the square root of 21 is bigger. How do I know that? The square root is an increasing function. So if I have square root of stuff, and I have square root of blah, and I know that stuff is smaller than blah, then I know the square root is also smaller. So really, some people say, well, if I want to minimize something, then I could figure out when the stuff under the radical is smallest, and it will happen at the same value of x and y that the whole thing is smallest. So that's the logic that's happening. But all that's doing is saving you from writing this. And to me, it's not that much work to write that. So that's the trade-off. Okay, so now let's go look at the one the student was asking about. They said in this exam, the instructor was minimizing the distance to this, and so they wrote this. And then they did this little trick where they squared and said we only need to I think the act of squaring, that does alarm me, but it's fine because of just what I said. But honestly, what's the next step? I didn't even pull up the instructor solutions, but I know what the next step is. And it would be to take the derivative with respect to x and with respect to y. And we could have done that here as well. It just would have been 1 over 2 times the square root of the mass. And then you would have had 2x minus 1 plus, is it just an x? Yep, plus 1 equals 0. And then you would have had 1 over 2 square root of the mass. And then with respect to y, it would have been 2y minus 3 plus 2y equals 0. So doing this little thing is not necessary. It's not wrong. I like it. I would encourage you to do it if you know. But I am just saying that it's a just unnecessary distraction, because then we could still keep solving. We get 2x minus 2 plus 1 is 0. We get 2y minus 6 plus 2y. Okay, so just wanted to make that point, that little maneuver is not a necessary thing to understand to do these problems. All right, I hope that helps.